Hello friends, in this session let us have a program for this particular question on 8051. Write an ALP for decimal down counter. So first let us understand the concept of decimal down counting in 805 and how it is going to work with the help of one example also. See, decimal down counter in the sense it has to start counting from 99 and it has to end up with the value 00. That's the down counting. And after 00 still move back means it must come back to the value 99. This is the procedure what we are having. So now with respect to the decimal, the way the program is being written is being shown here also. With respect to decimal, if you take, so 99 plus 99, if you make, the resultant value is 198, right? Now, this 99 will be in one register and this 99 will be in the another register, or we can just make use as a fixed value always, and the result will be always stored in the accumulator only. Accumulator can store the 8-bit value 98 and this one will go to the carry flag. So after 99, a decremented value 98 is what observable. Now take this 98, that is the contents of accumulator, add 99 once again to that one. Result is 197 and this 97 is stored in the accumulator and this one will go to the carry flag. So this is the decimal way of understanding this one. So in this procedure, whatever the value we have got previously 8-bit, add 99 compulsorily to that one, will get decremented value in continuation. So that's what we can observe over here. Now things in the 8051 are not going to happen in the decimal, that is going to happen in the hexadecimal, and we need to convert this hexadecimal value to the decimal value. See why we are doing that addition concept, that we have to understand clearly first. Right? Any of this is going to work for us, but why addition, why not subtraction, that we need to understand. See, question is with respect to the decimal operation. See, decimal operation, when it comes, we must make use of the DAA instruction. To use the DAA instruction, it works only after the addition or addition with carry concept, not with the subtraction instruction. Therefore, in order to have the result in the decimal, we need to use the DAA. Therefore, we are making use of the addition concept in order to get the down counting operation, not the subtraction instruction, right? So that's why this concept is being used. Now when it comes to the hexadecimal concept, so 99 plus 99, we are not going to get actually in the 8051, 99 plus 99 if we make, we are not going to get 198. We are going to have the result in the hexadecimal only, and that is equal to 132. Apply DAA instruction for this one, then this 132 will get converted to the required value. Anyhow, this one will be the carry flag affecting, and then 32 is what the accumulator content. After applying the DAA instruction, this value will get converted to 98. The same procedure is being continued further also, but anyway, let's have a clear understanding of this one with the help of an example. See the first value what has been taken, so that is being represented over here, right? So bit positions 0 to 7, then 99 the first value, so 9 and 9 bit patterns will be added with again one more 99, so bit patterns has been taken. If we perform the addition, so position wise, then we are going to have this value, and during the addition, whichever the carry flag, whichever the carry being generated to be carried to the next position, that is being represented over here, right? As per the observation, we can look into this one. From this position 3, after addition, a carry has been generated to the position 4. That means auxiliary carry flag is being set. Similarly, from the bit position 7, after addition, a carry has been generated. That means the carry flag has been set equal to 1. when it comes to the DAA instruction, it is going to work individually on the lower nibble as well as the upper nibble. But anyhow, based on the condition, it may work on it is going to work on both the nibbles. Right? In this particular case, as per the details of the DAA instruction is concerned, if auxiliary carry flag is generated over here, then 6 will be added to the lower nibble and carry is generated over here. So 6 is added to the higher nibble also. Right? So now as you can observe, carry is generated. This is 1 and this is 3 and this is 2. So that's what the 132 value we are going to have. Among this carry flag value, we cannot take it further for the DAA operation, but based on the flags affected, so we are going to apply the DAA for this one. So 32 is the value that has been taken over here. Then as per the DAA instruction is concerned, we are applying the DAA instruction, remember. So auxiliary carry flag is affected, so add 6 to the lower nibble. Carry flag is affected, so add 6 to the upper nibble. Therefore plus 66 is being written here, right? So after adding this one, so result we are going to get as 98, right? So decimal value what we required, 99 plus 99, we are getting over here, right? So same procedure is being repeated in each of the addition process. After each addition, DAA we are going to make use of based on the concept of the DAA. So the flags affected or whatever it is, 06 or 66 or 60 is being added based on the criteria to that particular nibble, and the value will get updated to the decimal value. Right? Now let us get into the program for this one. See, the program is as same as the program 13 that was previously discussed in the another video. The only change what you can observe is, so there we made use of add a comma 0 1. That's an incrementation operation. So decimal up counting operation, and here is the down counting operation. And as discussed in the previous theory, so add a comma 99h we have to make out. So that's why that one instruction is being updated. So everything else remains the same. Initialization we must make it equal to 99 because we must start from the highest number towards the lowest number. So highest number in the decimal 8-bit is equal to 99. So we are initializing accumulator to 99. Right, now let us go through the execution procedure. Now first value accumulator updated with the 99 starting point of the down counter. Then move that value to the port P0 so that you can observe over here, and value has been updated, initialized, and then after make a continuation with a delay and then add a comma 99h. So you can observe the value over here. We have got 32 and here is the carry flag that is being affected, and also you can observe auxiliary carry flag is also being affected as discussed in the theory, right? So now apply the DAA for this one. We are going to have the updated value 98 available in the accumulator, right? So again move back, update that value to the port 0. Now port 0 is going to have the value 98, right? So in order to have a continuous run of this one, so as I told in the up counter, so why we are going to have this delay and such a little bit more lines of the program. So the same thing is applicable here also. So now I will run the program. As you can observe the changes in the port P0 over here. So I am running. Now you can observe the value. See, values are changing quite faster. If you want to have a slow change over there, you can just update the value over here. Instead of 4f, you can put it as ff. Value, the execution speed will reduce, right? So now what is the observable? After 00, you must get back to 99, right? So you got 99. So this was the down counting, decimal down counting, right? Thanks for watching.